Hello and welcome to this lesson from Mod 8.4 about angle relationships. The learning target of this video is to correctly label angles and to use these definitions to solve problems. So first, we have to do the unfortunate boring thing, which is going over vocab. So there are 4 different terms that we need to know that help us either describe angles when we see them or to then apply what these definitions mean to solve problems around angles. So the first definition we're going to look at is for vertical angles. So let's say we take 2 lines and we draw them like this. Vertical angles are these guys right here, the 2 yellow ones or the 2 green ones. They are the ones that are on the opposite side of a point. So think about that, opposite side of the point. So here, let's do it the other. Here's one angle. To find a vertical angle, it's got to be on the other side of the point, and these are going to be congruent. That's a fancy word meaning they are the same. So the yellow angles, they're going to have the same measure. The green angles, they're going to have the same measure to one another. Next, let's talk about adjacent angles. Now, adjacent angles can take many different forms. So it could look something like this right here, where these 2 angles, or this angle in the light blue and the angle in the red, they're adjacent. It could be something that looks more like this. Put a line there. Again, we have one adjacent angle, and we have a second one. But the key thing you need to know for adjacent angles is that they share a side. All right, next we have complementary angles. Now this is a big concept. So vertical angles, complementary angles, and supplementary angles, they help us solve problems with angles. Complementary angles form a right angle. So that means it is 90 degrees, but we have 2 angles that somehow add up to 90 degrees. And they can be, it could be that line right there. It could be this line right here. It doesn't matter really. But what we end up getting is you have one angle plus another angle, and that when you add these guys together, so the yellow one plus the green one, it's going to equal 90 degrees. So that's what it means to be a complementary angle. Next, we have a supplementary angle. And that's very similar to complementary, but all we do is we change the sum. So instead of it being equal to 90 degrees, it's equal to 180 degrees. And so again, we draw our lines. The blue and the red, you add them up, they're going to equal 180 degrees. So again, just to recap, complementary angles, you have to associate the idea that this means 90 degrees. Supplementary angles, you have to associate the fact that this means 180 degrees. And just know that when we're adding 2 angles together and they're complementary, you set it equal to 90. That'll help you set up an equation to solve the problem. Next, let's talk about how we define angles, how we write them out, and also how we can apply some of these definitions. So here I want to walk through an example that the textbook has, and I'm not hiding like sort of what it says. I actually want to go through it with you here so we can kind of pick up on this. So part A, we have the diagram. It says name a pair of vertical angles. All right, now what I'm seeing, there's several ways you can go about it, but what I'm seeing right here, this angle X right here matches up with this angle right there. Now, again, another reason why I wanted to show you what the textbook has is how do we write angles? How do I know that I'm talking about this angle right here in yellow? Well, I take a look at the letters it has, B, F, and A. And if we look down here, they have those same letters. And so if you want to write about an angle, you use this little sign. It looks like a sloppy L or a sloppy less than sign, but it's just as tall as the letter. And then you write the 3 letters that are associated with it, but the one that's in the middle is the point. So we could write it BFA, or we could use the same notation and go like they did, AFB. And what that does is that means we're talking about this angle. And so go across of it, here we have DFE. And so that's why they're saying those are vertical angles. Now, if we wanted to, we could talk about another set of vertical angles. And so I could use this in green right here. Now, this is where it can get confusing, and this is why we have to use multiple letters when we talk about angles. I'm talking about BC, or I'm talking about the angle that you get with BFC and CFD. Or I could use the three letters I want, which is B, F, and D, and I say that it's a vertical angle to angle AFE. So how you write angle notation is really important because if I just say angle F, I mean, that means so much. I have to be much more specific. Even if I'm talking about like just angle C, am I talking about this side or am I talking about that side? So you have to use 3 points to make it clear what you're talking about. All right, now let's take a look at the next part. Adjacent angles. So adjacent simply just means that they share a side. So what the textbook uses is, what is it? AFB and BFD. Those are adjacent. We could also say that AFB is adjacent to angle BFC if we wanted, and say it's adjacent to that one. All of that works. All right, next, look for supplementary angles. Now, when we're looking at the picture, supplementary angles, or the picture that is a straight line. And so we have a couple of options here. Or we actually have many options. So here's one straight line that's going through, and that's what they end up using. So they're using the angle AFB, and then you have to use what's left. And so that's the other adjacent angle that we used earlier, BFD, right down there. If we wanted to, though, we could flip it, and we could say that angle DFE and angle EFA are supplementary because, again, they form that nice straight line. All right, and then, example D has us doing something similar, but now using a specific point. So you'll have to look around and see what we can use. So here, this one wants us to use DFE, and so we could either use this angle or you could use that angle. So you have a couple of options, and that's exactly what they did there. Next, I want to take a look at how we use this information to help us solve some problems. And so here's what we're going to start to see a lot of. We're going to see essentially equations that are disguised as angle problems. And so we see a straight line like this, and what that means is that these are supplementary angles, and so that its sum is 180 degrees. So the way we're going to find the measure of EHF is to take 2x plus 48 and set that equal to 180. That's how you do it. You have to first of all identify, what am I looking for? What's my possible angle sum going to be? Then you just have to realize it's like, all right, this angle plus that angle has to equal 180. And so then it just becomes a solving equation game. Subtract 48 from both sides. 2x equals 132. Divide by 2. X equals 66. Now we got to be careful. X equals 66, but that's not the answer to the question. The answer to the question is, what is the measure of EHF? And so what I have to do is go 180 minus 6, or something. No, don't do that. That's not what you want to do. Just take it, or take x and times it by 2, which we already have right here. And so that is 132. So 132 degrees. Now, I'm showing you that because you don't know what the question is going to ask. Here, the shortcut way of doing all of this was just to be like, well, you know, this angle sum has to be 180 degrees. I know the other one's 48, so I could just do x plus 48 is equal to, or maybe I would use a different variable. A plus 48 is equal to 180, and that would help me find that angle. Let's do one final example, and then we'll call it a day for the notes. So this one's very similar. The only difference is now we're looking at complementary. So the text highlights that for us. So, hey, notice that these are complementary angles. The dead giveaway is this little box right here. When they have that, that means it's 90 degrees. So again, they want us to find the measure of angle ZXY. They don't want us to solve for x. So if we just need to find this angle measure, all we have to do is go 35 plus A is equal to 90. Subtract 35 from both sides, and A equals 55. Done. But if we need to solve for x, what we'll do is something a little bit different. We'll go 35 plus 4x plus 7 equals 90. And again, I'm getting these from the two angles. So we have one angle, we have the other angle. I'm adding those two together to get 90 degrees because they're complementary angles. Now I have to do a little more work to solve for this. And so let's see here, 4x plus 42 is equal to 90. Subtract 42 from both sides, subtract 42 from both sides. Oops, 4x equals 48 divided by 4, and x equals 12. So I want to show you that just so that way you see it in case we end up needing it a little bit later. But again, it's just identify what kind of angle you have. Supplementary, complementary. Set it equal to the appropriate number, whether that be 90 or 180. You can either find the other angle or you can find x, depending on what it is you need to do. So that's angle relationships in a nutshell. Good luck with your homework. If you have any questions, please feel free to let me know.